Welcome students to standard 11. Let's begin with the subject physics chapter number 2 units and measurement. Before moving to the chapter units and measurement, I want to clear what exactly physics means. To start with, you already know what is science. Let me write precisely. It is a systematized and organized knowledge. It is systematized and organized knowledge about various natural phenomena obtained by three things. The very first, that is careful experimentation. Second is keen observation. And last, accurate reasoning. Sanskrit word for science is Shastra. Arabic word for science is ilm. ILM. Both mean same, that is organized knowledge. Moving ahead, science is basically classified into two categories. The very first, that is biological sciences. In the case of biological sciences, what exactly biological sciences means deals with the behavior of living things that we usually used to see around us. Various branches of biological sciences are botany, that everybody knows, related to plants, zoology, ornithology related to birds, organic sciences, etc. The second important classification of science is physical sciences. Physical sciences are majorly classified into two more categories. The very first is your physics. Second is your chemistry. Last but not least is your other physical sciences. For the case of physics, the study of natural world. Physics deals with the study of natural world, which deals with the concept of space, time, motion, matter, energy, radiation, etc. What exactly chemistry means? It is the study of It is the study of every substance its structure, its composition, and changes in which it takes part. Other physical sciences includes geology related to earth, geography related to structure, astronomy, astrology, oceanology, etc. Hope you are clear with everything. Let me revise one again. What is science? Is a systemized and organized knowledge about various natural phenomena which is obtained by careful experimentation, keen observation, and accurate reasoning. Sanskrit word for science is Shastra. Arabic word is ilmi. Both means what? Organized knowledge. Moving ahead with the science. Science is nothing but what? Systemized organized knowledge, having two major classifications, that is biological science. It deals with behavior of living things. Various branches of biological sciences are botany, zoology, ornithology, etc. Physical sciences are classified into three categories, that is physics, chemistry, and other physical science that is mentioned already. We have mentioned this. Now moving ahead, that is another term, that is scientific attitude. Scientific attitude. What does the scientific attitude means? Scientific attitude is nothing but open-minded approach. Open-minded approach towards solving problem. In which other important points of view are not neglected. Important points are never neglected in scientific attitude. That means open-minded approach towards solving problem, flexible enough to solve the problem. I can give you one example. If you are performing some experiment in order to derive the solution for some problem, if solution obtained, it is experimented first. In order to check the reliability of the solution that you have get, whether the solution is perfect or not, whether it is satisfactory or not. Experimented first in order to check satisfactory performance. If your performance is okay, then it is considered to be the final solution for that problem. Otherwise, you are moving to another solution that is replaced by a better solution. There is one more term, that is scientific method. What does the scientific method means? The step-by-step approach. The step-by-step approach used by scientists in studying natural phenomena, and establishing laws which governs these phenomena. is called scientific method. A step-by-step approach used by scientists in order to get a solution for the problem. That is nothing but scientific method. Moving ahead. What exactly physics is all about? Physics. Physics is originated from a Greek word which means nature. It was first introduced by scientist. Everybody heard the name Aristotle in the year 350 BC. Sanskrit equivalent of physics we have already discussed the Sanskrit equivalent for science. Can anybody remember what was Sanskrit equivalent for science? That was Shastra, and Arabic equivalent was Ilm. Similarly, Sanskrit equivalent for physics is Bhautiki, refers to the physical world. Is Bhautiki refers to physical world. More precisely, I can write that physics is a branch of science that deals with the study of basic laws of nature and their manifestation in various natural phenomena. There are various branches of physics. I'm not going to discuss every branches of physics in detail. That we'll see later on. That we are going to study in detail in chapter 1. But let me give you the overview of branches of physics. The very first, that is mechanics. Second, optics. Thermodynamics. We are having a chapter for this. Electrodynamics. Quantum mechanics. Relativity, and more so on. This was all about the basic of what actually physics mean. I have made you clear. Hope you all are thorough with the concept. Now moving with the chapter units and measurement. To start with the chapter, the very first topic, that is need for the measurement. What is the need for measurement? Why measurement is needed? Let us discuss first. Very first point, physics is an exact science which deals with accurate knowledge about the nature and the natural phenomena that we already discussed. Now, it expresses various natural phenomena in terms of the relationships among the quantity involved. You would be able to see that various natural phenomena are being expressed into mathematical equations which consist of various quantities, right? So this is what has been said into the second point. It expresses various natural phenomena in terms of the relationship among the quantities involved. Now, the exactness, or you can say accuracy, of these relationships depends upon the measurement we take, right? Here it is clearly said that exactness or accuracy of this relationship depends upon what? The measurements we take. Now, these measurements will in turn depend upon what? Accuracy of instrument, right or not? What you are taking measurement, that is liable on what? Instrument that you are using for taking that measurement. So, the next point, the accuracy of measurement in turns depends on the accuracy of the measuring instrument. And techniques. Hope it is clear. The recent progress in science and technology has been possible due to development of high precision instruments, right? Now, at present, one can measure with this high precision instruments mass as small as that of an electron. I can say 10 power minus 30 kg, and as large as that of the universe, 10 power 55 kg. See how big it is. 10 power minus 30, extremely small. 10 power 55, extremely large. Moving to the next topic. Next topic that is you're having into your syllabus is physical quantities. What do you mean by this word physical quantities? All those quantities which can be measured directly or which can be measured directly or indirectly, and in terms of which laws of physics can be expressed. Laws of physics can be expressed are called physical quantities. The quantities with which you are able to express the laws of physics, such quantities are called physical quantities. Hope it is clear. I can give you some example for that. That is your length, mass, temperature, speed, force, electric current, etc. There are so many examples. N number of physical quantities in universe. Now these physical quantities are further classified into two types of quantities. The very first quantity is your fundamental quantities. Fundamental, also known as base quantities. These are the building blocks of physics, in terms of which basic laws of physics can be expressed into mathematical forms. Now and second one, that is derived quantities. The name itself suggests. What do you mean by derived? That is extracted from some other quantities is known as what? Derived quantities. The quantities that are being extracted using fundamental quantities, such quantities are known as derived quantities. Now put the definition of fundamental quantities. The physical quantities which can be treated as independent of other physical quantities and are not usually defined in terms of other physical quantities are called fundamental or base quantities. Hope it is clear to all. I can give you the example for the same. Length. It is understood what do you mean by length, right? Is there any other physical quantity required to express length? No. Length has its sole independent identity. Similar, mass. Hope you do not need any other physical quantity to describe mass. Mass itself is self-explanatory, right? And it's independent quantity. That's why it is considered to be what? Base quantity. Time. Very good, etc. Now let us check what is exactly derived quantity means. The physical quantities whose defining operations are based on other physical quantities are called derived quantities. Are called simply the physical quantities whose defining operation means in order to define those quantities you require the additional fundamental quantities. Such type of quantities are known as what? Derived quantities. Example, force. Everybody knows force is what? Mass upon acceleration. Mass into upon or mass upon? Mass into acceleration. Mass into acceleration, that is force. You are writing F is equal to what? Ma. Yes or no? So force is equal to mass into acceleration. You are having speed. Speed is equal to what? Distance upon time. Yes or no? Velocity, that is displacement upon time. Yes or no? So you are basically having what? These quantities are derived from what? Fundamental quantities. So they are derived quantities. Moving ahead to the next topic, that is measuring process. Now what does this measuring process means? Have you went to market? If you want some quantities of ladyfinger, what you're going to tell? You're going to give them some idea that I need 500 grams ladyfinger. What he'll do? He'll put a 500 gram ready standard weight scale and he'll put ladyfingers on the other side. He's comparing or not? Yes or no? He's comparing the amount of ladyfinger with the standard weight. Therefore, measuring is nothing but the measurement of a physical process, of a physical quantity. You can say measurement is a physical process, or you can say the measurement of a physical quantity is nothing but comparison process. Is the process of comparing. What it is comparing? This quantity, comparing this quantity with a standard amount of the physical quantity, standard amount of a physical quantity of the same unit. Remember, of the same kind, or you can say same kind or same unit, is called its unit. Now to express measurement of physical quantity, two things you need to keep in mind. The very first thing you keep in mind, that is the unit in which quantity is being measured. Unit in which quantity is measured. And second thing you need to keep in mind, that is numerical value or magnitude of the quantity, I want to tell you one thing, that when you are I can give you one example. Suppose 500 grams, in which this 500 gram is nothing but what? Numerical value. Yes or no? Numerical value, or you can say magnitude of physical quantity. Yes or no? Yes. And what is this G? That is your unit. This entire thing you have to keep in mind while measuring process. Very first is what? Unit in which the quantity is being measured, and second is numerical value or magnitude of the quantity. Now what does this actually magnitude or numerical value means? The number of times that unit is contained in a physical quantity. Means from this example you can identify that 500 grams, since 500 times this gram unit is contained into that quantity, that is why it weighs 500 grams. Clear? Moving ahead, therefore measure of a physical quantity is expressed as numerical value of physical quantity cross multiplied by size of unit. Therefore it is expressed Q is equal to Nu, where N is what? Numerical value. Very good, numerical value. And your U is what? Unit, size of unit. Till this clear? Suppose I give you an example. If length of the room is I can say 5 meter or 500 centimeter. You'll be able to see that this 5 is what? Your numerical value. Yes or no? And what is this M? Unit. You have noticed over here something. What you have noted? If the unit is bigger, numerical value is small. If your unit is small, then your numerical value is big. Clearly I can say that the smaller the size of the unit, larger is its numerical value. Or vice versa. Hope it is clear. Smaller the unit, larger is numerical value. Larger is the unit, smaller is numerical value. I can conclude one relationship from here. Can anybody say? N is proportional to 1 upon U. If your size of unit is more, your numerical value is going to be less. If your size of unit is less, your numerical value is going to be more. From here I can conclude that Nu, that is equal to what? Constant. Nu is equal to what? Constant. If I can say 5 meter is the length of the room, or I can say 500 centimeter, is one and the same. Yes or no? Therefore this Nu is what? Constant. If N1 and N2 are the numerical values for a physical quantity Q corresponding to the units U1 and U2, then Q, that is equal to what? N1 U1, that is equal to N2. That is the same example. 5 meter, that is equal to 500 centimeter. This is your U1, this is your N1, this is your N2, that is your U2. Hope it is cleared. Moving to the next topic, that is physical unit and its desirable characteristics. What are the desirable characteristics for a unit? Clear? The very first characteristics I can say, before moving to very first characteristics, I want to define what is physical unit. What do you mean by unit? That is in the title of the chapter. Measurement, units and measurement process I have made you clear. Now what is exactly the unit mean? The standard amount of a physical quantity chosen to measure physical quantity physical quantity of the same kind is called a physical unit. Now very first characteristic is it should be well defined. Easily to be accessible, easily to be understand. It should be well defined. Anybody can understood what does it mean. That's why the first characteristic, it should be well defined. Second, it should be of convenient size. Why it is said it should be of convenient size? It should not be of very big value as compared to quantity, or it should not be of very small value as compared to quantity. It should be according to the or you can say in comparison to the quantity. That's why it is given it should be of convenient size. I can give you one example. Suppose you are having lady finger very small amount and you cannot put 3-4 kg weighing scale on the right side. It is not appropriate. Fine. That's why it is used. It is mentioned as it should be of convenient size. Suppose the amount of lady finger in the one plate is about 600 grams, and if you are putting 500 grams, it's appropriate. You can remove out any in order to make the balance. Fine. So it should be of convenient use. Third point, it should not change with time. Very important. It should not suffer any aging effect. Changing with time is known as aging effect. It should not change with time. That means whatever the weighing scale today is, it should not be changed after 5 years. It should be the same only. Fourth, it should be easily reproducible. Reproducible, you can say. Next point, it should be imperishable. Or I can say indestructible. It should not be damaged. Indestructible. Get damaged with time. It should not be affected by various external parameters. It should not be affected by various external parameters. Sir, what do you mean by external parameters? External parameters in the environments are what? Temperature, change in physical condition, you can say more precisely. Change in physical condition like temperature, pressure, humidity, etc. Clear? The next point, it should be internationally acceptable. Yes, very important. It should be internationally acceptable. Fine. Wherever you go, it should be one and the same. Next, it should be easily accessible. Last, that is, it should be easily accessible. Fine. These are the important characteristics of physical unit. Now the next topic you are having is units. We have already discussed the quantities, fundamental quantities, and second was derived quantities. We have already discussed the two quantities. Physical quantities we have already discussed right now. There are two types of physical quantities. The very first was fundamental quantities, and second was derived quantities. Fine. So for fundamental quantities you are having fundamental units. For physical quantities you are having physical units. There are two types of physical units. The very first is fundamental units and the second is derived units. The name itself suggests what are fundamental units and what are derived units. The fundamental units, the physical units which can neither be derived from one another, nor they can be further resolved into simpler components, into more simpler units, I can say, are called fundamental units. What are derived units? All other physical units which can be expressed in terms of fundamental units are called derived units. Let us take an example of derived units. Speed is equal to what? Distance traveled upon time taken. Yes or no? What is the unit for distance traveled? That is, you can say, I can write the unit of speed, that is equal to unit of distance divided by unit of time. Yes or no? What is unit of distance? Meter. Unit of time? Second. So I can get the unit as meter per second. This is nothing but what? Derived unit. It's nothing but derived. Fundamental unit example. Length is measured in what? Meter. Mass in kilogram. Yes or no? Time in seconds. Yes or no? Etc. can be what? Your fundamental units. Now very next important topic that we are going to study, that is system of units. Very important topic of this chapter. Now, before moving into detail of this topic, let us study what is exactly system of units means. System of units mean a complete set of units which is used to measure all kinds of fundamental quantities, fundamental and derived quantities is called a system of units, is called a system of units. Clear? Hope it is cleared. Complete set of units, whether we are using it to measure all fundamental quantities or derived quantities, the entire set of units is known as what? System of units. Now, the very first system that came into existence was CGS system. CGS system. CGS system, it was set up in France. It was set up in France, where this CGS stands for centimeter, G stands for gram, S stands for second. For the fundamental quantities, centimeter is a unit of fundamental units of which quantity? That is length. Gram is mass, and second is time. It was set up in France. I can write it is based on centimeter, gram, and second as the fundamental units of which three quantity? Units of length, mass, and time respectively. Clear? The second system was FPS system. Hope from FPS only you can get it out. It is a British system. It is a British system where F stands for what? Foot. P stands for pound, and S stands for second. Foot, fundamental unit of which quantity? Length, pound. Mass, second. Time. It is a British system based on foot, pound, and second as the fundamental units of length, mass, and time respectively. The next system of unit after FPS was Mks system. Can anybody guess what is Mks system? Where M stands for meter, K stands for kilogram, S stands for second. These are the fundamental units of quantities: length, kilogram for mass, and second for time. Hope it is clear. It is also a French system based on meter, kilogram, and second as the fundamental units of which three quantity? Length, mass, and time respectively. After all, the last system that is existing till date established, that is the International System of Unit. The International System of Units SI is the abbreviation. SI is the abbreviation for Systeme International that is the French equivalent, which is French equivalent for International System of Units. Hope it is cleared. This system was adopted. Next point. This system was adopted. Very important point. This system was adopted by 11th General Conference of Weights and Measures in 1960. This system gives 7 basic fundamental quantities and 2 supplementary units. 7 basic units, and or you can say it covers 7 basic units, 7 fundamental quantities, or it covers 7 basic units and 2 supplementary units. 2 supplementary units. I will list down first, second, third, fourth, fifth, 6th, 7th. This is your serial number. Basic physical quantity, then its basic unit, and last is symbol of the unit. The very first quantity, that is your length, the unit was meter, denoted by symbol small m. Second is your mass, basic unit is kilogram, and symbol for kilogram is kg. Time, second. Temperature, basic unit is Kelvin, named after scientist Kelvin. Electric current, named after scientist Ampere. luminous intensity, named after scientist Candela. CD, quantity of matter, or more it is known as amount of substance. Same, in some books it is written amount of substance. Mole, unit is mole. Remember one thing, the unit we write is MOLE, MOLE, and your this is mole. Fine, that is MOL. Luminous intensity is nothing but what the amount of light that is being falling on what a particular area. That is the luminous intensity. Candela CD, electric current ampere A, temperature Kelvin K, time second S, mass kilogram kg, and length meter m. Clear? Two supplementary SI units. Supplementary SI units. There are two supplementary SI units. Serial number, supplementary quantities, basic unit, symbol. Very first, that is plane angle. Basic unit is radian. Symbol RAD. Second is solid angle. Basic unit is steradian, denoted by SR. I will cover these two definitions in detail in the next video. Till then, you have a great time. Thank you so much.